Well, we've reached the end of another skill, so let's review what we've learned by taking a quiz. First up out of 4 questions. A UCS chassis has 8 connections per IOM. The discovery policy is set to 4 link. What happens when link 5 goes down to FIA? Now, I left this question a little bit nebulous on purpose because I wanted us to think through this scenario. The big question that we have to ask ourselves is, was the chassis acknowledged after being attached? Well, let's walk through the situation where we did not acknowledge the chassis. If that's the case, then our global policy of 4 link tells the chassis to, yes, come online only if you have at least 4 links, which we do, we have 8. However, it's only going to activate the 4 links, so links 1 through 4. As a result of that, D would be the answer. No network change would actually occur. Now let's walk through the scenario where we did acknowledge the chassis. If we acknowledged it, then that means that we are now taking advantage of all 8 of our connections. And as we recall, link 1 goes to server 1, link 2 goes to server 2, all the way on down. And as a result, server 5 would lose Fabric A connection. So D or A, depending on whether we made this underlying assumption, those would be our 2 possible answers. Question 2. Where does the VN tag header get inserted into a packet? Well, either you remember this or you don't. The VN tag header is going to go into the Ethernet header. So there's not a whole lot to go into as far as details are concerned, but yes, it is inserted into the layer 2 header, so A is our answer. Next up, which type of traffic flow is able to stay within a single fabric interconnect? Well, let's go ahead and start off by crossing off inter and intra IOM communications. First of all, intra IOM is sort of an oxymoron because even though we can communicate between 2 interfaces on an IOM, the traffic has to leave anyways. Inter IOM technically can exist, but that's nebulous enough that we don't know for sure whether it's going to leave the FI or not. All that to say, we know that we focused on inter and intra fabric communications, and so it comes down between the 2. And really, if our English serves us correctly, then we know that inter means between 2 different entities, whereas intra means within the same entity. And so hopefully that's enough to give us our answer. Intra-fabric communication is what is going to stay within a single fabric interconnect, and therefore B is our answer. And last question, it's a scenario question. An IT team desires to keep live migration traffic within a single fabric interconnect. What UCS config can provide this solution? So really what we have here is we have a single fabric interconnect, and we're going to be going down to multiple servers. So we have a VIC over here, we have a VIC over here, and we're going to have VNICs attached to the VIC that belong to a particular fabric. In this case, let's assume that this is fabric A. Now conversely, by the way, we are going to have fabric B over here, fabric interconnect B, connections up to the VICs, and we're going to have VNICs on fabric B, but that's not part of this scenario. We're only focused on a single fabric. Now I know I'm running out of space here a little bit, but we can see here that we're going to have V-switches attaching to both of these VICs via the VNIC, and so we need our VMKs that are attached to always go through fabric A. How are we going to accomplish that? Well, let's just walk through each one of these. So using port channel uplinks, we have to remember that port channel uplinks from a vSwitch perspective, that is not supported in a VIC topology. And the reason for that is we can't actually reciprocate. We can't port channel 2 VNICs together. Now using 2 different VMKs, first of all, that violates the premise of the question. It's not a UCS configuration, but also that's not going to help us make sure that all of our traffic goes out to a single fabric interconnect. So we're left with C and D. Now, if we have VNICs that are going to both A and B, this is where we have the potential of getting load balanced incorrectly. So remember that the V-switches are going to rely on pinning, and pinning is sort of a round-robin conversation. We don't know whether this VMK will get pinned out fabric A, or if it's got a second connection in here, let's just say we've got a connection out towards fabric interconnect B, well, maybe the V-switch is actually going to pin us out that direction. So the VMK on the left might get pinned out towards fabric A, and the VMK on the other server might get pinned out towards fabric B. And so that's not going to help us either. We need absolute control over this. So by deploying 2 different VNICs, both from fabric A, that will ensure at that point that all of our traffic stays within that. And it doesn't matter how many servers we have in the environment, this paradigm is going to apply to all of them. The key here, by the way, being that both of these VNICs should be configured for fabric failover. Because at that point, we do have redundancy between the fabrics. However, we're also maintaining control over the traffic conversation. And the reason that we use 2 VNICs, by the way, this is VNICs plural, the reason we're doing that is just so our hypervisor doesn't freak out and assume that we have a lack of redundancy on our vSwitch. All right, that wraps up this quiz. If you found that your map, the internal map that you're using, was missing some key pieces of information, then be sure to go back and watch the appropriate videos in order to fill those knowledge gaps. Otherwise, congratulations on completing Map Out UCS Network Pathing. I hope this has been informative for you, and I'd like to thank you for viewing.